right, hello everybody. My name is Dan. I'm here with Jami McLaren of J&J and Eric Eisenhut of NovaSterilis. Gentlemen, welcome to Sterilization Standards Week 2026.
Great to be here.
And we are here to get an update on the materials compatibility database. Now, Jami, we've talked about this before, right, here at AAMI, some of the progress that you people have made in this working group. What's still in effect, and have there been any developments?
Yeah, great question, Dan. So I'm really here today in facilities of the Kilmer Materials Group. So the Kilmer Materials Group is working on a new, what will be an online material compatibility database. It will support future revisions of AAMI TIR 17, which is for material compatibility. And we're working on that, getting that online hopefully later this year. But a lot of great work has gone into putting together the information that will support both TIR 17 and the database. And that's why we're very happy to have Eric here today to talk about some of the work that's going on with supercritical CO2 compatibility.
Well, you set me right up. Eric,
Great.
Talk to me about the supercritical CO2. What's going on there? What progress have you made?
Yeah, so supercritical CO2 is a novel modality. So in terms of the sterilization modalities available to the med device and pharmaceutical industry, supercritical CO2 is a newcomer. Having said that, we've been 20 years into this, and a lot of our material compatibility work has been around basic compatibility that a customer would bring to us. They would come with a device and we would go through an assessment on it. As we look to kind of becoming advancing, you look at TIR 17, and that really is a more quantitative assessment, and there's more standards to how that testing needs to be done. And that's where we're moving now. And so we've chosen a series of materials to go through that testing, falling in line with TIR 17, so it can compare well as others in the industry would like to see it and understand it.
Okay, so for my benefit then, a customer would come to you, they have a device that say, hey, we have this little gizmo, it's got nitinol, or pick a material, right?
Yeah.
Would it work with supercritical CO2? And then you're off to the races.
Yeah, and so for us, we're a low temperature modality. Very deep penetrating, minimally reactive. So there's reasons that somebody would look at a novel modality. Biological materials are very often a good entryway to needing a real low temp process. That's where we come in. And they would want to just assess, hey, how does my material respond? Not asking the question yet of sterility, but just, is it compatible? If we can establish compatibility as a baseline, then we can advance into dialing in the process variables such that they're really appropriate for the sterilization requirement as well as material compatibility.
Okay, that's awesome. Any ongoing work specifically that you'd like to draw attention to there?
Well, really driven by TIR 17, we've kind of focused on some of the polymers that are typical of the industry. So thermoplastics, for example, there's a whole series of them that the industry has historically used. And so even for devices that may have a special need for our low temp modality, they still will incorporate some of these other materials. Maybe it's a metal, maybe it's a plastic, and we need to address those. So we've been going through the ASTM standards, making sure they line up with how the TIR 17 requirements will place them, knowing that there's going to be a numerical standard that they get assessed against.
Understood, very helpful. And Jami, I want to zoom out just a little bit for context's sake. What's the context of the materials compatibility database in the industry right now? Because there's a whole bunch of very specific needs that will probably be met by this. But what was the impetus behind taking on this project and then bringing it to a fruition, hopefully in the coming months?
Yeah, and I think Eric summarized it really well. I think, when you think about a sterilization modality, of course we need to kill the bugs. But as I said in this seat, a few times before, a lot of times the material compatibility piece is the most challenging to overcome, especially when you have a new modality that maybe people aren't as familiar with, or that there's just not as much testing out there. So really the point of the database is to kind of accelerate the sharing of that data and encouraging people to share what they can to ultimately move the science behind sterilization forward.
Wonderful. And any advice or a call to action for folks who want to contribute to this project?
Yeah, I'd say if you have test data or test equipment or access to anything that could support new information going into the database around material compatibility, please reach out to AAMI. They can get in touch with me and the Kilmer Materials Group, and let's move this thing forward.